Hi guys, and welcome to your first tutorial on refraction. Alright, guys, before I start off with the chapter, there's one thing that I want to tell you. Uh, Now, this chapter has got a lot of information, detail, derivations, and reasoning in it. So, guys, Karan, we can't do everything with you. So, you actually, at the end of the day, that's what you have to do. And this is one particular characteristic of our physics tutorials that we can't do everything with you, especially on the numericals. So, please bear with us. And what we are looking forward to is your doubts. So guys, if you at all have any doubts, then please contact either your teachers or please feel free to contact us. We will be more than willing to help you guys out. That's our basic purpose. So let's straight away start off with the chapter. Now refraction, guys, as I already told you in previous tutorials, I'm using concise. So the definition that concise tells me is that refraction is a change in the direction of path of light when it passes from one transparent medium to another transparent medium. So guys, what this basically means is that if I have this surface right here, it's any surface, and this is my normal. The normal is always perpendicular to the surface, and if I have a light ray striking the surface this way, and always name the surface, always name all the lines that you draw, guys. This is M prime or M dash, as you may call it, and let's name the media 1 and 2. This medium, let it be air, and let this one be water. So guys, first things first, out of air and water, which one would you think would be rarer or denser? Now, I don't know how to explain this to you, but I really hope you've done this earlier, so um, so that I don't have to explain to you what is rarer or denser. But guys, please remember that air is rarer in the sense that it is thinner or it is less dense, less optically dense than water, and water is denser. So this is just like a thicker medium. That's how I would remember it if I were doing this for the first time. So guys, what do you think would happen, because we're talking about this big phenomena, refraction? What do you think would happen to the light ray? If you think that it's going to bend, then you're absolutely right. So which way would it bend? Would it bend away from the normal or toward the normal? Since in refraction we only have bending, so obviously if we talk with respect to this normal and time, then obviously it would either bend towards it or away from it. So guys, in this case, since it's rarer to denser, it would bend towards the normal. So it would go something like this. Alright, considering that, let's change colors. Considering that this was your initial, I'm sorry, considering that this was your initial light ray, and if there had been no refraction, it would have gone this way. This is the change. Now, teachers and the books might use a really fancy symbol, which is this. Don't get scared, it's only delta. Delta. And guys, delta denotes change. If you do take up sciences next year, then you have loads of deltas, okay, coming your way. So, this is just delta, and this delta just denotes the change in angle here. And this would be my I. And what would be the I? I is just the angle of incidence, and this would be my R. So if you can see, then so as you can see that this I should be equal to this angle right here, due to vertically opposite angles. And as you learn that in math, the vertically opposite angles are equal. So in this case, guys, our I would be equal to, what do you think? Guess, delta plus R. So from this we have that delta is equal to I minus R. So the deviation, guys, is I minus R, and this is what the first case is, where you go from rarer medium to denser medium. Now let me go over the other phenomena, which is not the phenomena. I'm sorry, the other case where you go from a denser. Oops! Look at that blunder. Where you go from a denser to a radial medium, and so all right. So yeah. So right here we have another surface. This time blue, and this is my normal. And n dash or n prime, and this is my m dash. This could be anything, guys. All these are variables. I hope you understand that. And now let me draw our incident ray. Here she comes. And guys, again, let this be water, and let this be air. And this, as you know, is denser, and this is rarer. So guys, if it all this, there was no refraction between the surfaces, I'm sorry, the line's not straight, but it would have gone something straight. So something this way. But however, because of refraction, this time, because it's from denser to rarer, it'll turn away from the normal. So if at all I had an incident ray this way, then my outgoing ray or the refracted ray would be this. So guys, this is my refracted ray. This was my incident ray. This is my incident angle, or angle of incidence. And guys, this is my angle of refraction. And what do you think would be the delta in this case? So what do you think is the change? Yeah, exactly, this is the change. This, here comes my delta, and in this case, guys, your delta would be equal to r minus I, as you can see. So guys, that's pretty much about it, about the refraction bit, the initial bit. Another quick way, this is a tip how you remember whether it'll go away from the normal or towards the normal. Because this is really confusing for some people. So guys, whenever you're going from rarer to denser, okay, so you have an RD here. So just remember that toward, okay, in English to say, in American English to say toward, and so toward is an RD in the end. So an R to D means toward, and toward is always with respect to the normal. So a rarer to denser ray would rarer to denser medium. If it also from rarer medium to denser medium, it will always go towards the normal. And the other case, which is if you have a D to R, in this case, obviously because there are two cases, you don't need to remember this one. It's automatically remembered. You have a way. So guys, R to D, rarer to denser, is in RD, which is toward, and D to R is nothing but away. Alright guys, so this is how I remembered it. In fact, this was my own innovation. Pretty good. It helped me out quite a lot. So let's see. It does take, again, it does take some time to get it in, because it's foolish for some people who are hearing this for the first time. But once you get used to it, you really find it helpful. Alright, so enough of my blabbering. Now let's go on to cause of refraction, guys. I'm not going to be writing anything because this is really basic. So why is it that from one medium to another medium there is refraction? So guys, the answer is that whenever a ray of light passes from one medium to another medium, its direction changes because of change in speed. Now guys, there's one thing known as density, one thing known as optical density. I hope you've discussed this in class. So the the two media are comparatively rarer or denser compared to each other. So in each media there is a different speed for the ray of light, which is why there is a change in direction. Now this is a very important line, that refraction occurs due to, I'm just writing cause, okay, due to change in speed. And why is there change in speed? Because change in optical density, right guys? So that's one thing you have to learn. Now we move on to laws of refraction. Okay, I'm sorry.